Welcome to Smart Academy. We are giving JEE Mains 2019 Physics question and with solutions. I am discussing the question with solution. So here I have one question here which came in JEE Mains 2019 Physics paper. A galvanometer of resistance 100 ohm. The galvanometer resistance 100 ohm has 50 divisions on its scale. 50 divisions on its scale and has sensitivity of 20 microampere per division. It is to be converted to a voltmeter with three ranges of 0 to 2 volt, 0 to 10 volt and 0 to 20 volts. The appropriate circuit to be is, here we have four circuits we have. So one is, this is a galvanometer, this is resistance 1, resistance 2, resistance 3, 2 volts, 10 volts, 20 volts. So here we have the four options. In four options, the values are R1, R2, R3. If we calculate R1, R2, R3 values, if it is suitable, what we are getting answers is matching with these three values, then that is the correct option. So here a galvanometer connected with a series resistance. So generally we know already a galvanometer converted into voltmeter. Galvanometer, if we are interested to convert to voltmeter, we have to add high resistance to galvanometer. We have to add galvanometer a high resistance in series connection. Then the galvanometer converted to voltmeter with range between the, for example, this is a 0 volts. So this is a galvanometer. We connected R1 resistance in series. Then the galvanometer converted to into voltmeter between the range 0 to 2 volts. Then one more option, the galvanometer connected the series resistance R2, then the galvanometer converted to between the range 0 to 10 volts. Between the 10 volts, the range between 0 to 10 volts voltmeter. Then galvanometer connected R3 resistance in series, then the galvanometer converted to voltmeter within the range 0 to 20 volts. Like that, first we have to calculate R1, R2, R3. So for that one, so here galvanometer resistance equal to G. So this is a galvanometer resistance, we let it be Z. Then current in galvanometer, that is Ig. So the current passing through galvanometer, that is Ig. Next, range of voltmeter, range of voltmeter, that is V. So for example, 0 to 2, this is the maximum is range 0 to 2. Resistance of voltmeter, R. So these are the general notations. So that is galvanometer resistance G, the current in galvanometer Ig, current in galvanometer, the range of voltmeter V, the resistance voltmeter R. So for this question we have to calculate here for R1, we want to calculate first R1, R2, R3. So first for R1, for calculating R1, so what are the values we have? So for R1 value, so we are calculating R1 resistance value. So for that one, so it is series connected between 0 to 2 volts. So then galvanometer resistance 100 ohm has 50 divisions on its scale and sensitivity of 20 microampere per division. So here 50 divisions. There are for one division 20 microampere current passes for 50 divisions. So for example, this is x into 1 equal to 20 into 50 microampere. So x equal to how much current is passing through per division for 50 division. So this is 1000, so microampere, so nothing but 10 power minus 3 ampere. So here the current in galvanometer Ig equal to 10 power minus 3 ampere. So we calculated first the galvanometer current equal to 10 power minus 3 amp. Okay, now we can calculate R1 value. So here current in galvanometer into galvanometer resistance plus R1 equal to the voltage difference between where we are converting the voltmeter. The range of voltmeter is 0 to 2 volts, so maximum value is 2 volts. So here Ig is 10 power minus 3 into G. Resistance of galvanometer 100 ohm plus R1 equal to 2 volts. So for R1, 10 power minus 3 by 100, so 1 by 10, 1 by, this will become 1 by 1000. So 0 0 cancel, 1 by 10. So here we will get so through R1 also Ig current is passing, so Ig into R1. So here 0.1 plus Ig 10 power minus 3 into R1 100 equal to 2 volts. So let it be this one, R1 only. So this R1 plus 100 okay children, now Ig into resistance of galvan, Ig into G plus Ig into R1 equal to volts. So Ig equal to 10 power minus 3 into 100 plus Ig equal to 10 power minus 3 into R1 equal to 2. So 10 power minus 3 is here, it is a common. 100 plus R1 equal to 2. 100 plus R1 equal to 2 by 10 power minus 3. So you will get 2000 here. So for R1 equal to 2000 minus 100. So you are getting 1900 ohm. So 1900 ohm. Every option R1 equal to 1900 ohm, 1900 ohm, 1990. So this is not option. This is not option. We have two options. So if we calculate R2, R3, then we can go for which is the correct option. So I calculated here 1900 ohm. Then I am moving for R2. So here for R2 resistance R2. See R2 where it is. The R2 resistance is connected with galvanometer in series connection. So in between the volt, see the R2 resistance connected in series with the galvanometer. So galvanometer converted to voltmeter between the range 0 to 10 volts. So now we can apply like this: Ig, galvanometer current, the resistance of galvanometer plus galvanometer current with R2 equal to the between range is 0 to 10, so 10 volts. So we can get here the value. So next one more R1 also there, so like that. So Ig into R1 equal to 10 volts. So the current is passing through here. So between 0 to 10 volts, 10 volts. So Ig into G, Ig into R1, Ig into R2. Now 10 power minus 3 into 100, 10 power minus 3 into R2, 10 power minus 3 into R1 equal to 10. So 10 power minus 3 take common, 100 plus R1 plus R2 equal to 10. Now 100 plus R1 already we calculated, 1900, R2 equal to 10 by 10 power minus 3. So that will be 10,000. So 100 plus 1900, you will get 2000 plus R2 equal to 10,000. So R2 will be 8,000 ohm. So here we calculated for R2, already we got the value R1 1900 ohm. So if we want to calculate R2, so I taken the circuit like this. So Ig into G, Ig into R1, Ig into G plus Ig into R1 plus Ig into R2. Then its total is equal to, is the voltage difference, 10 minus 0, 10. So 8000 ohm. So here 8000 ohm, R2 we got. If we go for R3 also we can calculate, but we got two values exactly. Then don't go for this option also. This is the right option. If you want to calculate R3 also, I will calculate here. So for R3, right. So this is a circuit for R3 total. So what happens here, Ig into G plus Ig into R1 plus Ig into R2 plus Ig into R3 equal to, so we connected R1, R2, R3 in series with the galvanometer. Then galvanometer converted to voltmeter between the range 0 to 20. So 20 volts. So here Ig take common, G plus R1 plus R2 plus R3 equal to 20 volts. So this is a 10 power minus 3, G is 100. So this is 1900 is 8000 plus R3, we don't know, we want to calculate that one only. 20 by 10 power minus 3, 20,000. So 100, 2000, 10,000. So R3 equal to 20,000 minus 10,000. So finally you get 10,000 ohm. So we got three options here. Three answers, not options, three answers. First, R1 equal to 1900 ohm, R2 equal to 8000 ohm, R3 equal to 10,000 ohm. So already I told that one, this is the right option. Here also we got same option, so this is the right option. Thank you.